Climate change is real. We need to move away from fossil fuels. We need to stop producing CO2. I think it's also informing people about the importance, the urgency and the sheer scale of what we have to achieve.
Decarbonisation is one of the key societal challenges of our time. Moving away from a fossil-based energy system to one that includes renewable energy sources and mitigates the effects of climate change is one of the key challenges that we face.
I think energy is one of the big challenges that the country faces, and if we can get technical solutions to the energy problems, not only will it benefit UK, but also there's tremendous export potential.
One of the unique aspects about Harwell, of course, is it's got these wonderful research facilities here so that it can cover the whole gamut of technical readiness from the very basic, all the way through to the deployment of technology. But I think it's important to anchor it in the middle in terms of innovation, and that's what the Harwell campus focuses on.
The Harwell campus is an exciting multidisciplinary environment which is a home to a number of national science facilities, including the Diamond Light Source, the Neutron Spallation Source, the Central Laser Facility, and it also sits at the heart of the Oxfordshire world-leading innovation hub.
Having the public sector, academia and industry all involved and as stakeholders inside our cluster model at Harwell campus means that we get much deeper and faster ideas sharing in a broader, richer ecosystem. We also have a fully comprehensive set of brilliant minds drawn from different places focused on the challenges of today.
Harwell campus is an innovation hub. It is a centre of innovation within the UK. It is centrally located with good road, rail and air links to the outside world. Having access to such a diverse range of scientists and engineers in such a central location is key to what Element 6 want to do, being part of an innovation community.
Here at Harwell we have three clusters, the Space Cluster, the Health Tech Cluster and the EnergyTec Cluster. And what is really powerful is that cross-fertilization between the clusters, the collaboration between industries working in those different sectors, which then in turn speeds up the penetration into new markets.
The public sector, academia and industry all have different viewpoints and they all have things to contribute. The academics are very able at thinking of new ideas. The industrial people have a very good idea of what they need to do. And the public sector often have large facilities like we have on the campus that can be used to address these questions. So you need all three to work in partnership.
I think now is a great opportunity for government to invest in the energy sector specifically, but also in Science Vale more generally. As we leave the European Union, that opens up great opportunities to us around the globe. Harwell, Science Vale already world leaders in the energy tech sector, and we need to ensure that we have the government investment to make sure that we can continue to lead the world.
The government created the Faraday Battery Challenge with an investment of £246 million from the Industry Strategy Challenge Fund. The purpose of that investment is to hasten the electrification of the United Kingdom. The money is going to be spent on research and development, on training, on understanding the policy implications of everything that we do, and on developing scale-up facilities so that the UK can have the most modern battery economy.
The Faraday Institution mission is to identify the challenges in research that, if they are addressed successfully, could lead to breakthroughs that would enable new innovative battery technologies.
I run the degradation project, and that's a project that involves chemists, physicists, material scientists and engineers, all focused on unpicking what's going on inside a battery. The UK has a large number of experts in so many different areas that, if applied to this project, put us in a position to make some real impact.
For the future, we're looking for passionate people interested in solving the global energy problems. The next generation of batteries will be developed by the next generation of scientists and engineers. What we're all looking forward to do within the Faraday Institution is provide them with the knowledge and capabilities, the sort of a toolbox to allow them to apply their talent in order to solve these issues.
Around Harwell there's a vibrant startup culture. One of our objectives in the Faraday Institution is to create small and medium-sized enterprises around some of the technology that we create new little companies, and having this sort of infrastructure around Harwell would be really exciting for us in doing that.
Energy for transport is a much neglected sector, and I'm sure that that will completely change from being fossil fuel based to being maybe ammonia based or maybe hydrogen based or something we haven't even thought of yet.
If we're to make significant changes to our carbon emissions, then we need to be developing the technologies we will need right now.
If we are successful in addressing the challenges around a solid-state metal battery, we'll be able to provide a technology that is a leap forward in terms of energy density and safety. It will provide a competitive edge to our UK industry, in particular automotive industry, to be competitive and relevant internationally.
This is really a natural place for us to locate.
We're doing something new in the UK, we're doing something exciting in the UK, we're doing something that could transform the UK's opportunities.
We need to come up with a clean solution to the internal combustion engine, and I think that that's just chemistry.
Welcome to the Harwell Campus. Thank you for being here today to celebrate the great launch of the new EnergyTec Cluster and the opening of the Faraday Institution headquarters here at Harwell. I am Barbara Ghinelli, Director of Campus Business Development here at Harwell for Science and Technology Facilities Council, which is part now of UK Research and Innovation. When I came in this room just a few minutes ago, I had actually a really warm feeling, because I suddenly remembered that almost exactly 7 years ago, I was here launching the first pillar of our first cluster, the space cluster here. And today, how exciting to be here again, together with my colleagues from the Faraday Institution, to launch these two major initiatives, which are really going to make a huge difference to the energy sector in the UK. We know that the clean growth is a global challenge, which is at the heart of our UK industrial strategy. Our aim for the EnergyTec Cluster, together with the Faraday Institution within it, is to make a huge impact in developing the UK energy sector, addressing the need for electrification, for intelligent energy systems, the generation, storage of clean energy and other solutions, whilst inspiring and retaining here in the UK the next generation of our scientists, engineers and entrepreneurs, which will really be the foundations for the future of this sector. We have such strengths here and depth of multidisciplinary capabilities at Harwell, which are really highlighted by that unique concentration we have of special national science facilities, which are concentrated all in the same place. And the EnergyTec Cluster is designed to marshal these assets, to actually help us make best use of the assets that we have here, to embrace clean energy and to actually reduce as much as we can the impact on our environment, which is such an important cause. We want to create an efficient pipeline which sees cutting-edge R&D being transformed into commercial products and services, which will really make a difference to the way we're actually generating, storing, and disseminating energy. This will open up major opportunities for businesses as well, and will help our economy to thrive, as well as protecting our energy security. The clusters provide a really unique set of tools in order to deliver these aims. And EnergyTec is part of a well-established entrepreneurial environment which facilitates collaborations, the risk sharing, as well as making it easier to attract investments and gain economies of scale and tap into a large pool of highly skilled labor, as well as being an ideal environment for developing and commercializing new energy products and services. This also provides an environment where we can test these products and services in real life situations, so the so-called living laboratories. So that means making sure that what we generate, what the new products that we create, are usable by real people and that really meet their needs. The success of our clusters also depends on the wider relationships that we have with the exceptional innovation ecosystem in our doorstep in Oxfordshire, as well as reaching out to the expertise elsewhere in the UK and also our international links around the world. So I'm really very excited to have the Faraday Institution here at Harwell, because this will provide yet more focus and impetus to our collective efforts and will also further strengthen our links to university research all around the country. The Faraday Institution also joins a core of businesses here with Williams, with Siemens, Ricardo Energy and Environment, and many other businesses already here, alongside the activities of our national facilities, which sit at the heart of the EnergyTec Cluster. But the development of EnergyTec has also been driven by the SDSC, EPSRC, Innovate UK, which now are all part of UKRI. And also by the Oxfordshire Lab and other very important key partners, campus partners, that work in different but related sectors, such as the European Space Agency. This spirit of collaboration, which is exemplified by the organization of this event itself, it sits really at the core of our ethos here at Harwell, cutting across disciplinary silos and also bringing together the full weight of our knowledge and expertise to innovate, but also, most importantly, to actually derive the benefits of that innovation. So I really am looking forward to see this new cluster take off and really make an impact, a tangible impact to our productivity and our society. And as we're doing already with the Space Cluster and the Health Tech Cluster, we really want to see EnergyTec to change the dynamics of what we call multidisciplinary innovation and the impact that this will have to our growth and our society. And we want to do this here, but also elsewhere in the UK to really get that competitiveness going internationally. Innovation is really about bringing people working together collaboratively. And here we've got a fantastic nucleus of people and organizations. I'm sure you will experience that all the way through today. So I hope that many more of you will join us in this very exciting endeavor, and that many of you will decide to work collaboratively with us with the years to come. Because really together we can change the way we live for the better, so improving our quality of life, and I think most importantly help to safeguard our planet for the next generations. So next we are going to play a video from the Right Honourable Greg Clark, MP, Secretary of State for Business, Energy and Industrial Strategy, who wanted to be here very much, but unfortunately for urgent parliamentary business wasn't able to join us today, but has sent us this video. So I hope you enjoy the video and you enjoy the rest of the day. Thank you very much for your attention.
Good afternoon, it's Greg Clark here, the Secretary of State for Business, Energy and Industrial Strategy. I just want to say that I'm sorry I can't be with you this afternoon. It's frustrating, but we have votes in the House of Commons all through the afternoon and evening. But I just wanted to say how important your work and this institution is for our future. As you know, it is one of the most significant and most talked about parts of the industrial strategy, making sure that we build on the skills and the academic brilliance that we have in this area of technology to establish a lead in what is going to be, right across the world, a transformational set of pieces of research and innovation. We have a lot to draw on. The Industrial Strategy Challenge Fund has allocated £250 million to the Faraday Challenge, a sign of the significance of this work. But of course it's the ingenuity, the creativity of everyone that's engaged in it that's going to make the difference. It's important for a project that embraces the whole of the UK and internationally as well, that nevertheless there is a headquarters. There couldn't be a better place than Harwell to be headquartered. I look forward to joining you to see for myself your new headquarters very soon and to talk about the work that you're doing. But I hope that the rest of the day goes very well.
So good afternoon. I want to thank all of you for coming to the joint Harwell EnergyTec Cluster launch and the opening of the Faraday Institution's headquarters located within. Thank you, Barbara, for introducing us. So I'm Peter Littlewood, I'm the Executive Chair of the Faraday Institution, and the Faraday Institution has been set up to be the UK's independent institute for electrochemical energy storage, science and technology. I would like to thank virtually, the Secretary of State for giving us all this money and for his message and support. It's actually good to know that the significance of what we're trying to do is actually appreciated at the highest levels of government. And he in particular has been a champion of positioning Britain as a leader in battery technology, and in fact announced the launch of the Faraday Battery Challenge last year. He's also been a great supporter of the energy revolution, which he has acknowledged will be achieved by boosting science and innovation, which is a key aspect of both Harwell and the Faraday Institution. I also want to thank Harwell, our founding universities, our board members, several of whom are here, Tony Harper, the director of the Faraday Battery Challenge, who will be speaking to you in a little while, Catherine Magnet from UKRI, EPSRC, many of that team, and you, our invited guests. We chose Harwell as our location because we see here all of the component parts of a sustainable innovation ecosystem. We have some of the world's best research facilities for basic science, which are critical for energy storage research. This, of course, includes the diamond light source, the ISIS neutron and muon source, but not least those researchers who work at those institutions and produce the great science which comes from that. We have deep support from UKRI, EPSRC and SGFC, which make our scientific world go round. And not last, the entrepreneurial environment, a startup culture that really helps new energy businesses to add value and create jobs, and will help the UK reach its energy and decarbonisation goals. The Faraday Institution exists because the world has reached a tipping point. Michael Faraday himself invented electrical energy science of the order of 200 years ago, having been given the battery by Alessandro Volta and exploiting that to develop the dynamo, the electric motor, and technologies within that. And of course the technology came first, the science came a little bit later. Colleague of mine, former colleague a long time ago, James Clerk Maxwell, used Faraday's insight to construct the theory of electromagnetism, which has powered science for generations beyond that. That was the first start of electrification. We've now reached the point where the electric vehicle is becoming the preferred mode of transportation on the grounds of efficiency, on the grounds of cost, and on the grounds of environmental footprint. And all of those three things coming together suggest that this transition will move very quickly and we need to exploit it. As it comes, the continued electrification is going to make a new economy. It is not just vehicles, it will reinvent sectors from transport to power generation and distribution and eventually to banking. And electrical storage is the key technology to make this viable. So the Faraday Institution's role is to be here to support the basic research necessary to enable our world-class universities to discover new materials so that our electric vehicles go farther, last longer, and we hope will be made here in the UK. So we're bringing together scientists and industry partners on research projects to reduce battery weight, cost and volume, to improve performance and reliability, and to develop whole life strategies from mining to recycling to second use. That's the work we're doing today. Equally important is the work we are doing for tomorrow. We're here to train the next generation of scientists and engineers who will bring into being the next generation of batteries, which will take us further toward energy independent. So to help meet those objectives, amongst the many things we've started, I'm proud to announce today the creation of the Michael Faraday Scholars Program. This is an undergraduate scholarship for meritorious students from financially and socially disenfranchised backgrounds who wish to pursue science and technology degrees with an emphasis on energy storage science and engineering. The Scholars Program is named after Michael Faraday in tribute to his application-inspired spirit. Faraday rose from the working class in a time when science was reserved for the elite to become one of the greatest scientists of the 19th century. But a brilliant and self-made man, he devoted his life to discovery through experimentation. This scholarship program, available to students attending universities in the United Kingdom, will officially open in June and will cover tuition costs over 4 years. I'd like to segue from there to a modern hero for batteries, for whom we've assembled a panel today to honour. That man is John Goodenough. In 1979, not far away in Oxford University, John Goodenough showed that by using lithium cobalt oxide as the cathode of a lithium-ion battery, rechargeable battery, you could make what became the power of the personal electronics revolution. That revolution, which happened in personal electronics, which was delivered by lithium-ion batteries, and everybody owns many of those today, is now moving into electric vehicles. And those scientific achievements, which we'll hear talked about a little bit in a moment, give us an opportunity to actually unveil a plaque in his honour. Unfortunately, John can't be with us today, but he has sent us a message which we will play in a moment. But before doing that, Barbara and I will pull a string over here so that you can actually see the plaque, and we'll read it out to you. I'll try pulling the string. It's dangerous.
Obviously, you have to hold it down.
Oh, very good. Thank you. Right. So I'll read this out. In recognition of his leadership in the scientific discovery of the lithium cobalt oxide cathode, which led to the lithium-ion battery that has transformed our lives in the UK and throughout the world. So John, congratulations. And I think John has a few remarks from a distance.
Good friends and colleagues, I greatly regret that I am not able to be with you on this occasion to congratulate you on your new center. You have been commissioned to address one of the most important problems facing the modern world. It is now widely recognized that modern society's dependence on the energy stored in a fossil fuel is not sustainable. A fossil fuel, once burned, is not recyclable, and the exhaust gases pollute the air, contributing to global warming and already choking large populations in cities around the world. It is necessary in the near future to be able to harvest the energy that comes to us daily from the sun. We can harvest sunlight and we can harvest wind energy as electric power. And we can transport that electric power to distributed sources. But you can't use that power unless it is stored. And the most convenient place to store the energy is in a rechargeable battery. Therefore, your commission to develop a transformational rechargeable battery is an extremely important task and challenge. And I wish you luck in all your endeavors. Not luck, but good success. So, my best wishes to you all. Thank you very much.
John, you will understand, is a very special man who continues to be active in research right to this day. So we have assembled a rather stellar panel who will highlight a moment in time and the incredible discovery from a team led by John. But the narrative is in fact much broader than this. From that discovery came the next generation of battery science, as I say, a revolution in personal electronics and a revolution to come in electric vehicles. On this panel, you'll have an opportunity to hear from those who were present with John during the moment of discovery, students who've gone off on their own successful careers, representatives from Harwell who can speak to the transformation over the decades on campus to meet national energy challenges, and also from a leading automotive company who's benefited from the moment of electrification in the UK in the form of new products and new markets. So I would now like to turn this over to our panel moderator, Professor Clare Gray of the University of Cambridge. Clare.
So I'm Professor Clare Gray from the University of Cambridge, and I'm here as one of the founder members of the Faraday Institution, and I'm also here as one of the leaders of one of the Fast Start projects on degradation. And I'm also here because I was an undergraduate and a PhD student, or a DPhil student, when John Goodenough was the head of inorganic chemistry up the road in Oxford University. And we're here obviously to celebrate John's work and that discovery in 1980 of the lithium cobalt oxide battery, and that will be a lithium cobalt oxide cathode material, which was the first high voltage material, and it really transformed the whole space, as others in the panel will articulate in more detail. And this was discovered in Oxford and then patented via Harwell, and that's then started some of the connections with Harwell and the institution here. And as I mentioned, I was here because I was an undergraduate under John Goodenough, and I benefited from his notorious and well-known lectures, and it was there that I first heard about spinels and layered materials and polarons and electrons moving around as a second-year undergraduate. And I still pull those notes out, and I still struggle to convey those messages to senior PhD students N years later on. And those of you who heard and continue to hear John's lectures will know exactly what I'm talking about. Massive insight into the chemistry, the physics, and the engineering of these systems, but also sometimes challenging for us all to follow, but very much inspirational. And I think one thing that we have to celebrate here today is not only the legacy of John's inventions and his discoveries, but also the legacy that he left for the UK in solid-state chemistry and energy materials. And so I grew up in a department where I thought that solid-state chemistry was the only form of inorganic chemistry. I didn't worry about molecular chemistry and molecules. I thought everything was about what was going on in the solids. And that's how I left Oxford University and carried on my own career in working on solid-state materials. And so with that, I'm going to pass you over to Peter Bruce, who will describe in more detail the beginnings of the lithium cobalt oxide revolution in Oxford. So thank you, Peter.
Thanks, Claire. I think it's sort of remarkable to think that it's only a few decades ago that probably no one in this room would have actually thought about a battery. Apart from a few rather odd people who might have been interested in it in those days, it wasn't something most of us really considered. I mean, it powered flashlights, started your car, and that was about it. And it was really the introduction of the rechargeable lithium-ion battery that changed all that. That, as we heard from Peter, Littlewood powered the mobile revolution. We have tablets, mobile phones, although we're frustrated by how quickly the batteries die, that nevertheless these are remarkable technologies that have been enabled by the lithium-ion battery. And all of that really started with John's work. I remember John is now, 96, so he did this work at a relatively late stage of his career, which gives hope for all of us. It was the discovery that he made of lithium cobalt oxide in Oxford in those days that really made the production ultimately of the lithium-ion battery possible. And at the time, I mean, many people believed rechargeable lithium batteries would never happen. That was the conventional view, certainly of the battery industry at that time. And those more enlightened people that thought it might firmly believed that it would be based on transition metal sulfides as the cathode, not oxides. And everyone told John he was crazy and wasting his time studying oxides as cathode materials. They would never work. And of course, it was that discovery a number of years later that enabled Sony to commercialize the first lithium-ion batteries. So there's a lot of lessons in there, including don't listen to too many people when you decide what to do. Think for yourself. And I think, of course, that invention enabled, as I said, the first generation lithium-ion battery and much of the portable electronics revolution that we're used to. But it isn't enough to power the next generation of electric vehicles or to store electricity from renewable sources. So we need another transformation in battery technology. It'll still be based around lithium, probably, but it needs to have a next generation lithium battery, and that's really what the Faraday Institution is enabling to deliver, to carry out that fundamental research that will hopefully unlock the door towards the innovations in battery technology and put the UK at the head of that game for the next wave of the battery revolution.
Thank you, Peter. Phil, do you want to take us away from life in day one of the lithium space?
Well, I wanted to start actually by saying, talking about a moment in time, and sometimes we're very lucky in our careers. I was sitting, finishing off my PhD, my DPhil in physics in Oxford, desperately wondering what I'm going to do next, and I was marking practicals, third-year practicals in the optics lab up at the top of the Clare laboratory in Oxford, and in walked this giant of a man. And basically I went out in the corridor for about 5 minutes and he'd offered me a job. And that was it. So I ended up working for John Goodenough, principally looking at the structures of all these materials. But I just wanted to sort of talk about the difference as well between discovery and invention, because we talk about the discovery of the lithium battery, and really it was invented. It was very much a set of rational thoughts. And of course I came the year after the lithium cobalt 8 first paper. But I was there at the beginning of the Spinell story, and I just wanted to relate, because I've been in the room when and just seen an invention occur, and sometimes it happens in a moment, and it's bringing together the minds of different people, and I want to talk about Mike Thackeray, because Mike unfortunately can't be here, but Mike is another of the giants in the lithium battery world. The NMC, nickel manganese cobalt materials that you talk about, that's Mike's cathode invention, and Mike came over from South Africa with a bag full of spinels. And spinels are semi-precious gems. And John actually, and I remember John saying this, he said, it's not going to work. Spinels are gemstones. You basically can't get lithium in and out of a gem. Now, what Mike had brought over was iron oxide, the spinel form of iron oxide. And I remember John saying to Mike, so why are you working on Fe3O4? And Mike said, because it's cheap. And that actually is something that drives in the NMC world, that's away from 111 to 811 now. It's the price of cobalt. So he was prescient in that and saying that then. But John said, well, I'm going away to India for 2 weeks. And he said, I want you to see what you can do in the next 2 weeks. So Mike and I worked day and night over that time, and it worked. And we'd shown actually that we could get that to work, get the lithium in and out, and we'd done that chemically and we'd done it structurally. And so John came back after 2 weeks, summoned him in the office, and so I'm in the middle here and I was the small man. So you're John Goodenough and you're Mike Thackeray. And so John said, so did it work? And Mike just said, yes. And John just sat back in his seat, and you saw the man now. He's a remarkable man still, but I was in awe of the man. I could only ever call him JBG. And John sat back for about 20 seconds and leaned forward and said, you'd be better with manganese. And that's why we have LIM 204. It was as simple as that. It was over in a moment. And in some ways, actually, when I wanted to relate that, in some ways, the story seems to stop. John goes back to the States, and yet an awful lot happened after that. And a lot of that actually circles around Harwell. And actually, I have a student working with Faraday now, and Chris Wright and Jerry Barker are there in the audience. And Chris, of course, was part of that story in Harwell. In fact, Chris headed up I think it's the non-nuclear ops at Harwell at the time. Chris is the one who brokered the deal with Sony. And so you should talk with Chris about that story, because it's a wonderful story in its own right. But from Harwell, actually, not only was there this deal struck with Sony, but there's a lot of money that was invested afterwards into coating lines, into dry rooms. And a lot of that history actually exists in this room, because there's a lot of you in the venture-backed spin-out companies, battery companies in the UK, and a lot of you can either trace your equipment, whether it's dry rooms or some of your senior staff, back to the days of Harwell. And so, here we are today, and in some ways, I think this is like, Harwell 2.0. We're back again, with this massive investment of funding in terms of the Faraday Institution. We're here with better opportunities that we had than Harwell did in the 1980s, because we've got these big facilities that are crucial to the understanding of these materials. And I think Mark may be saying a little bit more about that in a moment. So here we are, and I firmly believe, and working with Faraday and with others, that we have to focus on innovation, and we academics have to support that innovation event, yes, but also inform innovation in terms of the answers that we get. And Clare, with her initiative in degradation, is very much part of that, understanding industry's challenges and the challenges in batteries in terms of making them better and bigger and lasting longer. But here we have the opportunity at Harwell to make that look quite tight, because we have to accelerate from the invention through the innovation through to the industrial employment. And here we have the opportunity and the ecosystem, and we talked about the EnergyTec clusters today, to be able to accelerate that so that we have invention and innovation and the ability to do industrial deployment and development, working with WMG and others in terms of the Advanced Propulsion Centre work up at Warwick, to really make a difference. And I think there's a fantastic opportunity. There's some wonderful people in the room. There's an even more wonderful generation coming through. And I think we have to give them the opportunity to make these differences. And I hope that this place here at Harwell and the Faraday Institution will be the catalyst to kick that off.
But before you finish, I just want to ask you one question. When was the first time you heard John's laugh?
Oh dear.
And what inspired it?
Oh, I don't know. Peter can answer.
Maybe Peter has.
It happened often, actually. I can't remember the first time.
For those of you who have not heard John's laugh, which we didn't get on the video, it could be heard across the whole of the inorganic chemistry lab. It can be heard across many DOE meetings. John is somewhere around when the laugh emerges.
Yes,
from long distance.
I was in Philadelphia with him 2 weeks ago, and he was getting an award, and I walked into to the room. They had breakfast for us, and before I got into the room and I was in the corridor, I knew where John was from his laugh.
Mm-hmm.
Yes.
I actually have his laugh.
Well, go on, let's hear his laugh.
Let me see if I can get this to play.
Do you want a mic?
No, hold on, I think this will.
What's it?
The miracles of technology.
So I wasn't making it up, but let's return a bit more seriously. So, Mark, would you like to follow on from that?
I'm not sure how I can follow on from that, actually. So I'm Mark Thompson. I'm the new Executive Chair of STFC, which is part of UK Research and Innovation. So as many of you will know, UK Research and Innovation is the new science organisation in the UK. It brings together the 7 research councils, Research England and Innovate UK, under one umbrella body. And the intention is to provide a powerful single voice for research and innovation in the UK. Now, one of the aims of UK research and innovation is to strengthen interdisciplinary research and the connection to innovation. And I think battery technology and energy technology is one example which fits absolutely into the UK research and innovation model. As we've seen or heard, battery technology brings together physics. I'm a physicist, so that bit I just about understand. Chemistry, which I understand less of. Technology. But also, I think Peter mentioned this as well, the policy implications. There's a deep connection to policy. So I see the Faraday Institution and the EnergyTec Cluster as really fitting in very, very well with the overarching aims of UK research and innovation. Now, those are all very nice words, but what we're really trying to do here is bring together the best minds from science and industry together in one place to collaborate on a very challenging problem and to address one of the key areas of the government's industrial strategy. That's really what we're trying to do here. So I view what we're doing today as having huge potential. Of course, we have to work to realise that potential. I think it really is a major opportunity for the UK in the research and innovation landscape. I think it does 2 things. So the first thing it does is builds on a successful model of clusters. And really the idea there is people come together, you get a community of researchers and innovators. They're all close together, they can communicate closely, and that has a very positive effect. That's clearly a strength of what we're trying to do here. And the other thing really is it's building on the substantial investment in the facilities we have on the Harwell campus. And I'd like to say a few words about highlighting really what we have on the campus that brings us, I think, a particular edge here. So the unique nature, I think it probably is unique, of what we have at Harwell, is we have probes of materials, different types of probes of materials. So we have neutrons from the ISIS neutron spallation source. We have a very advanced electron microscopy suite, so we probe materials with electrons as well. And we have light, either from the diamond light source, the synchrotron radiation, or from our lasers, our very powerful laser sources at the central laser facilities. And these are all probes of materials. So we can study battery materials or enable the users, the scientific research community, the industrial research community, to actually get a deeper understanding of the material science that underpins battery technologies. So I would see this as a toolkit for advanced battery research, and that's one of the unique capabilities we have at Harwell. Now, I asked my colleagues at the various facilities to give me a few examples of how their own technologies, neutrons, photons, or light, actually impacted battery technologies. I have a 6-hour lecture course now I could give, but I won't. So I would like to just give a couple of examples of the way collaboration between research, industry and innovation can really build and have a positive feedback effect. So for example, at the CLF, they're developing very intense, compact, coherent X-ray sources specifically for studying battery technology. So you can tune what you're doing to the actual technological problem in hand. So that's one area where we're applying technology to specific problems. Another good example is the X-rays from the diamond light source, and there was as I understand it, there was a problem a few years ago with a mobile phone manufacturer had problems with batteries, and they were significant problems. And that company put in significant resources to investigate the sources of those problems, many people and a large amount of money. Now, the unique thing we had at the Harwell site is we had the right tools. So in this case, the diamond light source was the right tool to actually probe the material science and actually understand what was going on inside these rather, in some ways, simple objects, batteries, but actually the complex material science that's going on in them, within those. So that really is the competitive edge that we have at Harwell. We have the toolkit that enables us to move beyond just large numbers of people looking at a problem. We have excellent scientific researchers, excellent innovators, and we have the tools that enable us really to push the technologies. So I think that's an important point to note. We have that competitive edge. The other thing we're doing here is obviously the government and industry have built up a lot of investment on the Harwell campus, so we're really building on that investment and using that investment. So I see this launch today actually as a significant step in pursuing this important strand of the government's industrial strategy. It's a real opportunity for the UK, and really what we're doing, as I say, is bringing together people. People are our most valuable resources. The Faraday Institution will build training the people with the right skills to actually address this problem, and they're coming here on the Harwell campus to work and collaborate together and to actually utilise these unique facilities we have on site. So I think this is absolutely really potentially a very, very important day for the UK research and innovation.
Thank you. Do you want to?
Okay. Good afternoon, everybody. So I'm Paul McNamara from Williams Advanced Engineering. And in terms of the value chain that we've sort of been through in the panel, I think I am very much at the end of that in terms of how do we apply this lithium-ion technology or anything else into components, parts, and systems that can fulfill something. So I guess everybody knows Williams from the Formula One team. The history of how advanced engineering came about was to handle things that were outside of Formula One, but which the company wanted to get involved in. And the path into batteries was very much through the rules of Formula One, because the kinetic energy recovery systems came in 2009. We actually developed a flywheel storage system in parallel with a lithium-ion based system. Us, along with all the rest of the teams, eventually decided that the lithium-ion storage was the right way to go, and the flywheel technology went off to other applications, and we sold that on elsewhere. So that was our journey into it. And the thing about lithium-ion from our perspective is it's an electrochemical device, but we've got to shroud that in mechanical devices, cooling systems, crash protection systems, and control systems that get it to interact with the rest of it to make that work in an application. And the great advantage we have in starting in motorsport is motorsport in the Formula One world only requires 3 or 4 cars a year, and you can experiment in that sort of enclosed environment and develop things. The Formula One rules changed over time, and come 2014, the energy storage system had to come from your engine supplier, which in our case is Mercedes. So all the investment that we had built up over that time, we needed to redeploy. And redeployment for us was into Formula E. So Formula E, if you're familiar with it, is an electric car racing series. And I think it's the manufacturers of cars starting to recognise that with the way the market's developing, we need a showcase for the prowess of manufacturers in electric cars to sort of compare the technologies. But to get that series going, they mandated that the battery would be the same for all the teams. And that was really to keep the cost down with the new series, and also to mean that somebody couldn't run away with it with a really great innovation in the batteries, so somebody was just miles ahead in the grid, and it ruins the spectacle. Anyway, so Williams set about making those batteries for the cars, and for the last 4 years we've been making 50 batteries at our site near Grove, just near here, and that series will continue. But for us, that sort of set the scene for a company that had grown out of a motorsport need to use lithium-ion into how do we apply this into other systems there. So now we're working very much with road cars, so we're a beneficiary of all this technology. We work with car companies generally at the stage where you're trying to make 10 prototypes, 50 special cars. We're not mass production, but how do you take that, take the learning from motorsport, take the front end of it, and then apply it out into an industrial sector. So for us, and we have grown the company very significantly on that just in the last 2 years. So lithium-ion has sort of been a great commercial success for us, as well as and we were the recipient of the Queen's Award for Innovation just a couple of weeks ago for what we've done in Formula E batteries to take that forward, so to recognise that everything we have taken out of the research community and applied it into the world, so we're very much the beneficiary of it. But for us, the Harwell Institution being located here and becoming the headquarters is absolutely great for us. We see ourselves collaborating very closely with that. We're just located very near. What we want to do and what we want our role to be going forward is the great work being done in the lab and academia and front-end companies we can take through, because we have that ability to make 20 practical batteries that can then go into a prototype scheme, or 10 special batteries that will run in a motorsport series or something, and we think that can help accelerate stuff out of the laboratory into the commercial world quicker than what's ever gone before. Because what I always say, being an ex-internal combustion engine guy myself, my early career, is the internal combustion engine guys had the benefit of 100 years of development of that particular technology to get where we are today. We're going to have to try and repeat that across the next couple of decades or shorter, because that's going to be the take-up in the car park out there, and we've got a lot of learning to do quickly, and we think our company working with Harwell can contribute to that. Okay.
Thank you, Paul. So I thought I would end by just telling you a little bit more about the Faraday Institution and the things that we're doing from day one. So as I mentioned before, I'm the leader of the degradation project, which is one of 4 fast start projects. Peter Bruce here is leading the lithium metal anode, and so that's about trying to see if we can use lithium metal in the next generation of lithium-ion batteries and solving the many challenges associated with that, but hopefully to lead to batteries of larger and higher energy densities. Then we've got 2 other projects on modelling, and that's about connecting the electrical signatures that you get from the battery and then using that to understand the processes inside the batteries, develop models so that the engineers can then operate batteries under different regimes and understand how that might then lead to degradation or to better performance. And the final project is about recycling and life cycle analysis. So we're spanning a whole gamut of activities, from the very fundamental understandings of how different processes work right through to trying to understand the systems or the information that's needed to build better battery management systems. And I think it's very exciting for many of us, because it provides a new way of creating a new community in the UK, of taking existing experts in battery chemistry and engineering and materials, but also harnessing a lot of experts in different areas, from those people who are in beamline scientists using the facilities in Harwell, or using other facilities that the UK has to offer. And the other thing that provides a really interesting opportunity for us is to use the Harwell campus and the ability to market ourselves to industry, but also to work with industry to take on board the needs in a much more interactive and real-time response mechanism than is possible if we're sitting siloed in our different laboratories. And I speak myself very personally on this, because I'm possibly the most fundamental person in the project or in the activity. You know, I do things that are very, very molecularly oriented, and the connection between my science and a real impact is there, at least in my mind, but it takes a while for it to be translated. So I think it's very important that we have these structures, and I'm personally very excited by this opportunity to be here and work in this integrated team. So with that, I thank you all for listening, and I don't know if anyone else wants to add anything, but and thank you to John again.
Thank you very much to all the panel for the fascinating discussion. And now we have Tony Harper, Industrial Strategy Director, Faraday at UK Research and Innovation. Thank you.
So, fascinating discussion. Thank you. So, as Barbara just introduced, I am the Industrial Strategy Challenge Director for the whole of the Faraday Challenge. If any of you have any difficulty remembering what that is, it's the chap with the Secretary of State, £250 million, and the accountability for making sure that we generate real impact with it. So before we finish today, I'd just like to give some reflections on what I think has brought us here today, and then a bit of a call to arms about the future, although I've heard an awful lot from everything that everybody's said has given me real confidence and enthusiasm that call to arms will be well met. So like many things, the reason that I'm stood here and the reason that you're all sat there has come about through the confluence of a number of things that happened at the same time when motive meets opportunity. I'd been involved in my previous job. I was Director of Engineering Research at Jaguar Land Rover for quite some considerable years. I'd been involved in the Automotive Council. And batteries had been on our radar, if you like, for many years, for 10 years. The first roadmaps that were done by the Automotive Council Technology Group were probably 6, 7, 8 years ago. It was one of the fundamental 5 original themes of the Automotive Council, and there'd been Innovate UK programs, certainly, and APC programs that had supported it. But what happened what happened about 18 months ago, roughly, was that we went beyond recognizing it as a key technology to starting to look at what it actually meant as the automotive industry moved forwards in an electrified world. How many of these batteries do you think the UK will actually need? What does that mean as an industry? And when we started to do the numbers, our jaws really started to drop. You can take relatively median views of the transition to electrification over the next few years in UK car plants and convince yourself you need around 50, 60 gigawatt hours a year of capacity. That's 2 Tesla gigafactories. You do the same maths for Europe, it's 15, 16. Yeah, it's absolutely huge, and this is by 2030. So fundamentally, you stand back from that and you go, okay, well, we've got these projects. We've got a bit of Innovate UK money, and we've got some APC money, and we've got some, but heck, this is just a massive opportunity for the country as we move forward. So that was the one sort of foundation stone, if you like. The other one was actually. Peter Bruce and others, I think, at the time, were thinking about how the academic community could be more sort of organised toward in a multidisciplinary, challenge-based way, and how we could put together something a little bit along, I guess, pharmaceutical lines. You were saying, Peter, as to how how could we get more critical mass? How could we get more multidisciplinary cooperation, and how could we make that application inspired? To make a real difference in the academic world. And then the third element was the opportunity. Was the industrial strategy was starting to be formed around that time. The government were thinking about what are the first waves of challenges to be supported. The kind of criteria are that there must be a massive business opportunity. We must be technically capable of exploiting that opportunity. It must be something where the funds would make a difference. And batteries ticked all the boxes. I'd also say there was a fourth as well, because obviously the climate around cars, around air quality, around CO2, I think had gone from being of concern to being of critical concern. And it meant that in the car industry it became much more risky not to invest billions in electrification than to invest billions in electrification. And fundamentally, right now, the car industry is investing billions in electrification. So those, for me, are the things that brought us here at this point in time. The call to arms is that we have 246 million pounds. Thank you, Jackie. It's 246 million pounds over the next 4 years. Obviously, we want to extend that. We want that just to be the beginning. But the call to arms is really to work together. To work together to make the opportunity that we have of this huge market for batteries in the UK. Do we watch them come across the channel in barges made somewhere else, or do we get high-value jobs in R&D and manufacturing here in the UK out of that opportunity? It's the latter we're doing. The 246 million, everything that everybody here does in this room today and over the next 4 years, and hopefully over the years after that, is to fundamentally load the dice in favour of the UK exploiting that opportunity. And I would ask everyone to work together. We've got the three big elements of the Faraday Challenge: the institution, the collaborative R&D, and the industrialization. I've already heard unprompted from everyone about the importance of working across the innovation ecosystem. Everybody has also talked about leveraging investments that have already been made, using every other opportunity we have, whether it's through clustering, whether it's through the leveraging of investment through STFC, and also the opportunities that we have now of all being part of UKRI. Yeah? My job is, I don't work for Innovate UK really, or for any of the research councils. My job is across UKRI to deliver the impact with all of you. So with that, I heartily commend this project to everyone, this quest to everyone, people sometimes ask me, why did you leave a great job at JLR, to come and do this? Well, just look at it. Look at it. It's an absolutely fantastic opportunity. So please let's work together to exploit it. Thank you very much.